Okay, I'm going to start right now.
The broadcast is now starting. All attendees are in listen-only mode.
Welcome to everyone to the DBA Fundamentals virtual chapter meeting for October. Today's presentation is entitled Changing Your Habits to Improve the Performance of Your T-SQL. It's going to be presented by Mickey Stuewe. I'll be turning things over to Mickey in a few minutes, but I want to bring a few things to your attention first. First of all, you can put all your questions in the QA field on your screen, and if you have any technical issues, raise your hand, raise your hand icon, and one of the two of us that are trying to work on behind the scenes will try to answer your questions. You can also send a chat message to either Mark or DBA Fundamentals, and we'll try to answer that about technical things. If not, put your questions out there, and as we go along, Mickey's going to try to answer your questions related to the screen she's on. The session will be recorded, and the web broadcast will be available in about a week. Maybe a little bit earlier than this weekend, but just in case, we always guarantee it at least a week. You can get to the archived session through our DBA Fundamentals website, fundamentals.sqlpass.org. Go to the Archive tab, and that way if you can't catch the whole presentation, we know people have to leave, things happen, or you get disconnected, you can check back in a week and be able to see it. I am not sure if the discount code VCSUM09 is still available for $150 off for the Pass Summit in Seattle. If it's not, you still ought to try to talk to your boss about a late-minute move to try to go. That's November the 4th through the 7th. I'm going to be going for my first time, and I'm really looking forward to it. If you do try to sign up, and if you get your boss to agree to it, try the discount code VCSUM09, or you can get it from any other virtual chapter. We don't care, just as long as you save $150. Speaking about that, there's local chapters in probably within driving distance of every city that we're probably listening to, and if not, there's at least 25 virtual chapters. So go to SQLpass.org and sign up and become members of each virtual chapter that you feel interested in. And there's so many sessions out there. And I was just talking to Mickey before the broadcast started about how I've been DBA for 3 years now, and I think that my learning has advanced dramatically because I'm associated with PASS, and I work with PASS, and I work with all of the different training sessions. There's just fantastic education out there. My name is Steve Cantrell, and I'm the chapter co-founder of the DBA Fundamentals Virtual Chapter Group. You can send any of us questions at any time, and you can find out our contact information by going to fundamentals.sqlpass.org and looking in the About Us tab. You can contact me at stevecantrell22@gmail.com or on Twitter at SQLSelect. In November, we're going to have Amy Levin presenting a session called In-Memory OLTP, the Ultimate Performance Frontier. We had a session about in-memory OLTP earlier that Microsoft did for us, but Amy's going to try to give a different spin to it, so be sure and try to sign up for that. That'll be November the 11th. It'll be after Pass. I think that's everything I can think of right now, so let's get started. Again, like I said, Mickey Stuewe is going to be presenting Changing Your Habits to Improve the Performance of Your T-SQL. Mickey is a database architect. Her focus is on database modeling, T-SQL optimization, and report design using the SQL Server stack. She's the recipient of the Best New Community Voice Tribal Award from RegGate. She blogs regularly and co-authored her first book, SQL Server 2012 Reporting Services Blueprints. She's spoken at Dev Connections, SQL in the City for RegGate, and various SQL Saturday events. In fact, that's the first time I met Mickey was at the Louisville SQL Saturday, and I just loved her presentation and the way she explained things at a level that anybody could understand. So you guys should really be looking forward to this. So I'm going to turn it over to you, Mickey. I'm going to mute myself and take it away.
Thanks, Steve. I really appreciate that. And it is very hot here in Southern California today, so I envy anybody who gets to wear sweaters. I don't think I even own any sweaters anymore. So I'm happy to be here, and I'm looking forward to our presentation. So let's go ahead and get started. What we'll be talking about today is kind of two different fronts to help you improve your SQL or help your team improve your SQL, since I know many of you are probably DBAs and wanting to bring up the standards of the app dev people who write SQL or the SQL developers that you have. So the first few slides we'll talk about is how to better display and to provide information in the SQL itself. And then we're going to go into some details about various aspects of things that you need to take a look at to make sure you are writing better SQL. So let's take a look at the first one, formatting T-SQL for readability. This may seem like a no-brainer, but some people don't really think about it, or they're in a hurry, and so they leave it off for later. But it's very important that you include some basic information in the SQL, in your stored procedures and your views and the user-defined functions, so that the next person who comes in is able to quickly assess what's going on and fix any problems or improve the queries that they're looking at. So it's good to have comments, the original author, and a brief audit trail. The reason why I say a brief audit trail is you really should be using some sort of repository for your code, some sort of source control. And there's various products to do it. There's the hard way of doing it, of scripting out your SQL and then manually checking it in, or there's tools. I don't work for Redgate, but I'm a huge fan of the Redgate tools, and they have some tools that will help you check your SQL directly into your source control repository. That way you can have really long comments about what you change, especially if it's complicated, and you can put it in there, and then brief audit trail inside of your SQL. Also, it's very important to be consistent on how you lay out your SQL and where you put your comments, so that you can read SQL quickly. Because if you've got a huge library, I know one of the guys that's online here has a lot of databases, and he doesn't know all the stored procedures because he didn't write them all. So he is going to need to be able to quickly assess stored procedures he's never seen before. So if they're laid out in a consistent manner, he can go in and look at them quickly. But the thing that is the most important is whatever pattern you pick, it's the one that is used by everybody. It doesn't matter if your commas are on the left or the right, if everything is uppercase or lowercase. You need to have something that is consistent and that your entire team buys in. And sometimes that's hard because they want to be lazy and put everything on a single sentence, and you don't want that. You want it to be laid out nicely. Now, this is my particular preference, but it's something that kind of gives you a flag in the sand to tell you, to what kind of things you should be looking at. Spelling words out. One of my biggest pet peeves is when I see a table in a database I'm not familiar with that is just a whole bunch of letters. RG46. Well, what exactly does that mean to me? Okay, that is not helpful. So spelling the words out. I personally don't like spaces or special characters. The reason for that is later on, if I want to create some scripts to manage all of my databases and all my SQL, I have to make sure square brackets are in the right place, or that the data isn't parsed by pipes or dashes because I know they're in the stored procedure names or the schema names. So try not to use those special characters. I've seen strange ones. I've seen question marks. I found slashes in one the other day. So be careful what you're doing. Indent subqueries. I'll show you that in a minute, how hard it is to read a statement without the subquery indented. because those are the things that can be a performance suck if they are not done right. So by making sure they're laid out properly in your SQL, it'll be easier to pinpoint them. Don't be afraid of capitalization and using that. I'm a big fan of having the first letter in each word capitalized, but whatever it is that your team is comfortable with, keep using that. And it may be that you've had a standard that you hate, but it's in 500 databases. Well, don't change it in the middle, because then you've got two different standards now that you've got to maintain. Maybe on all new databases, go to something that is easier to maintain. Comment, 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 and remove old code. If you're using a repository to hold your source code, that will have all the old code in case you need to go back to it. There's no reason to comment out 300 lines of code because you don't need it anymore in your 500-line stored procedure. And yes, I have seen that. So one of the things that I did at a company, 2 companies ago, is I wanted to educate my whole team on writing better SQL, because I was the one that was doing all of the code reviews, but I wasn't the one writing most of the SQL. The application developers were. So what I did is, actually it was there already and I added SQL to it, is we had a document for coding standards. The reason why I call it a living document is it will constantly change. You want to put the least amount of standards in it that will make everybody happy, because too many rules makes it too easy to not follow them, right? Think of all the driving laws that are out there. I learned new ones when my 16-year-old went through driving school, because they had changed since I was 16. And so you want to put the least amount. But on the flip side, if you're having trouble with people doing things that you don't like, then make sure that is in the document. And the reason why I put the case statement here is the manager I had at the time was a little obsessed with how the case statement was laid out. And so we had to make sure that it was put in the document the way that he liked it. And I think this was the thing that I failed my code reviews the most, because I didn't understand why it had to be exactly like this every time. But he was very fanatic about it, and so it went in the standards. And I really liked the way we laid it out, where we had the correct way and then we had the incorrect way. The incorrect way was the way that I saw all the time in everybody's code, and that way they saw what the best way to lay it out. Another thing that I did is I sent an email out to my team each week, and I included one tip. I think I called it Tech Tip of the Week. This is actually how I started blogging. I did it internally for a year, and then I started blogging outside of the company. Sometimes I would include an important blog post that talked about something about performance, or to back up why I did the things that I did. If I had a new template, which we'll talk about in a minute, then I would include that, or areas that I saw that needed improvement. Maybe everybody kept putting no check in their foreign key constraints, and I need them to stop, and that was in the standards not to do that. So I would send a tech tip about why that's not a good idea, this is the right way to write it, and you will pass your code reviews if you do it the way I'm requesting. The other thing that I did is I provided templates. Templates are ways, you can have a template that says this is the best way to write a stored procedure, it's got a comment block, it's got error handler, and that will allow you to give them something to start with. And that way you know that at least their starting point will be consistent with everything else that you have in your database. Now, there's some really great things that you can do to create these generic templates. One is to create a catalog of templates, and I put my templates in my source control repository. If you're using products like Team Foundation, TFS, Team Foundation System, I can't remember the S. TFS is what we all call it. It's a Microsoft product. You can tell it where to put various branches in the TFS code. So you can go into where SSMS keeps their templates, and have your catalog populate there, and then tell everybody, hey, I put some new templates in the catalog, please go to the repository and download them. It'll make sure you have standard code, and SSMS provides a way to parameterize your templates. It has 3 parts. The first part contains the field name, so this is your prompt to say what you're asking for. Then you can provide a data type. Most of the time I use string, but you could put date time or int if you prefer, and then you can put a default value. If you don't have a default value, then you can leave that empty, but you do have to still include that second comma. Then to use this template parameter, you use Control-Shift-M, and that will pop up a dialog box with all of the template parameters for you to populate. So let's take a look at one. So first, I did mention that SSMS has a place to put templates. You can find it in View Template Explorer. It's docked on the left side of my screen, and it says Template Browser. And it comes with all these various templates. I created a folder for all my demos and a subfolder. So here's our demos for our presentation today. The great thing is when you double click, it gives an instance of that template. So now I don't have to worry about hitting Control Save and ruining my template. So what we have here is a script. Say I was using this all the time. I used to just put a code that reminded me that I needed to put the database here. So what I can do instead is put that template parameter and put database name, string, and maybe my default database is AdventureWorks. AdventureWorks 2008 R2. Okay, so now I have this great template. I can then save it in my template repository, or I can keep it wherever I want. And now when I want to use it, I do Control-Shift-M, and it pops up the dialog box. Now, I'm not actually using the AdventureWorks 2008 R2, so I'm going to go ahead and type over that, hit OK, and it shows me what it now puts in there, the database name that I requested. Now, say I had to put that database name in several places. What I can do is put the exact same parameter. Maybe I'm just going to put it down here just so you can see what I'm talking about. And now when I use Shift-Control-M, it only shows it to me one time, but it's going to put it in both places. So now I know that I can reuse it wherever I need to in my template. Now there is another product that SQL Prompt is a product by Redgate, and they will also allow you to use templates. And I have one here called New, and what it is it's mixing both something that Redgate provided me and what SSMS provided me. So here we can see that it automatically popped up my template parameters, and it has a value here, demo programming, DBO, my Sprock name, great Sprock, and I can put a short description. And when I hit OK, it populates everything for me, and I now have a template that I can continue to use. Now, I'm not going to go into SQL Prompt because that's not what this presentation is about, but you can contact me later if you would like to find out more about it. Again, I don't work for Redgate, but if you saw on that first slide, I am a Redgate addict. So here I have, in this particular template, a drop if the SERP procedure exists, because this is for a brand new SERP procedure, comment block. I have a nice error handler down here, and this is a template that I can give everybody to go ahead and have a starting point for their STAR procedures. Is there any questions yet? Steve, do you see any questions you'd like me to answer right now? Okay, well, I'm going to go ahead and keep going.
I'm sorry, I hadn't
Now
unmuted.
let's get into...
Mickey,
Oh.
I'm sorry, I hadn't
Yes.
unmuted myself. Somebody asked a question earlier about what do you do when you come into a team and there are no SQL coding standards before you got there, and you don't want to spend your time rewriting everything.
That's a good question. That's when you do need to make a decision. Do I want to start implementing standards from here on out in the existing databases, or do I only want new databases to follow the standards? I've done both. If these databases, if you're not going to have any new databases for a while and you want to start including standards, what I do is I only apply standards to the new code, even when I'm modifying a stored procedure. For instance, say I have a 200-line stored procedure and I have to go in and modify a subquery in one of the selects. Say there's 10 selects in this stored procedure. In that subquery, I would apply my standards. I would apply the formatting standards that I have, as well as any other standards that I might have. You know, I like my commas on the left, so I would put my commas on the left there. That is a hard thing to do, to not go in and fix everything in that stored procedure. Because I'm a little OCD, okay, maybe a lot OCD, there were times where I wanted to format the whole thing. The problem is it can cause other problems if you're not careful. If you have a product that can do the formatting for you, like Redgate can with their SQL prompt tool, then you might go ahead and format the whole stored procedure, but not change variables until you are modifying the variables. One more question and then I'll keep going.
Okay, and this is just along the same lines. Can a smart folder structure create an unwieldy system? I'm sure it can, but you just have to be careful with it.
A smart folder system?
I'm assuming he was talking about the point where you were talking about the different levels of folders you had for the templates.
Oh yeah. I try and keep those very broad. Let's go back to that. All of these folders, except for a demo, came with SQL Server. So if you were to go into the template browser, I think it might be in 2008. I'm not sure. I do know it's in 2012 because that's what I'm working in. So all of these are already here, and you can go and see what's in there. I would, for my templates, I would probably keep them to the object type. Here are some templates for creating these kinds of stored procedures. Here are some for doing performance tuning. Here, here I have one for reporting because it's a query that I use quite a bit. So yeah, I wouldn't want a lot of folders. You do have to be careful for that very reason. All right, let's keep going. I would wish I could answer everybody's questions. Oops, I went too fast, but we do have a very large group today. So I came from a VB programmer background, and I programmed in VB long enough to say I programmed prior to .NET. And even in college, we were taught to modularize. That was the big thing. You want one screen of code to be in one function or one method. That is not the best choice all the time for SQL. SQL is a set-based language, and so you have to really be careful when you break up the SQL. I have seen people try and improve performance by breaking up the stored procedures into multiple stored procedures, sending the data back to the C# code, and then merging it back together to get the data they want. I about had a cow when I saw that. Please don't do that. But what you want to do when you're writing the SQL is minimize the data as quickly as possible. You don't want to, if you do have to break up the query into multiple statements, you don't want to do all the data manipulation up at the front and then use the filtering at the very end, because you might be manipulating 1 million rows of records when you only need to return 10. So if you can minimize to the 10 rows as quickly as possible and then do whatever data manipulation that you need to do. So that's something that you really need to get across to, especially application developers. They don't think that way. They think about modularizing, and what they really need to do is think about narrowing the data and allowing the SQL to determine when to, the execution plan will determine when the data will get minimized down to the final select statement. I'm not saying don't use temp tables, but you know, you want to minimize how many SQL statements that you have in your stored procedures. So let's take a look at predicates and set theory. One of the things that can hinder performance are using non-deterministic functions. Deterministic functions are ones that return the same results every time. And here is some examples. Deterministic functions, if you're using the left function to return the first 3 characters, it's always going to return the first 3 characters for that row. It's not going to return 5 later on. The same with the len function and the data len function. Non-deterministic function examples would be getDate. Every time you use it, it's going to return the date and time of that second or that millisecond. So every time it's going to return a different value. Now, if you notice that I actually have the convert function in both of these lists, the reason for that is when you're working with some data types like date time, the convert function may not return the same value. So it's actually behaving as a non-deterministic function when you're using that data type. But if you're using a varchar, then the convert is deterministic. Sorry, I pushed the button. So you do need to look into what kind of functions you're using to make sure that they are not hindering your performance. The like operator is another one. When you're using the like operator with a wildcard, you try not to, I know sometimes you have no choice, try not to put the wildcard at the very beginning of the string. When you do that, it cannot use the index, and then you might get a full index scan or a table scan. If at all possible, you want to structure your statements so that it will use index seeks when possible, because that will give you the best performance. When you are also using a whole bunch of different predicates in your where statement or your from statement, if you can write it in such a way that you're using ands instead of ors, that will help improve your performance. Now, I didn't include in. If you are stuck in SQL 2000, I apologize. I'm sorry you're still there. In had very bad performance when you're in SQL 2000. When you get to SQL 2012, they improved it, and they slowly improved it along the way so that your in statements are not horrible anymore like they were in SQL 2000. But you do have to be careful of them if you're still back in those older databases. Union and union all, those, if you can use a union all, it will be better performance than union statement. The reason for that is it will not check for duplicates. So if you know that you're going to union 2 sets of data, maybe coming from 2 different tables, and you know that there'll never be duplicate data, then use the union all, and then that will save you some milliseconds or maybe even seconds, depending on how much data is coming back. If you want to see an example of that, I have one on my website. Implicit conversions. Oh, these can be a pain. What an implicit conversion does, it sounds wonderful when you first see it, is it's going to change the data type automatically for you. Woohoo! The problem is, It may not change it to the data type you are expecting, in which case it can actually hinder performance. I would encourage you to take a look at the data type precedence list. You can Google that with the word MSDN, and it will take you to this link, and it will tell you what order the data types are selected. Now let's take a look. Oh, here we go. I have my short list before I show you the demo. Data types do matter. This goes back to the very beginning of creating your tables. You don't want to be changing data types between tables for the same field. You want to keep it consistent. Sometimes we inherit databases where the field has changed. Maybe they were using varchar for a name, and then they went international, and so the new tables have nvarchar. Well, that's going to cause an implicit conversion. The things that you can do to prevent that is to use the cast or convert functions to make sure that you convert it previously to do the matching. But it can still cause a problem if you need to change data types, because we saw earlier that the convert function can be non-deterministic when it is using the date-time data type. So let's take a look at how to find these implicit conversions, because you can find them in their execution plan. So what I have here is I have a demo. We're going to go ahead and make sure we're using the right database, and I turn statistics on. Now I wanted to show you what the data is that we're working with. I have a table here that has 4 columns and a primary key. This column is a varchar holding numbers, holding the exact same numbers but as an actual number. This particular column is holding dates, and then this is a varchar holding the exact same dates. Okay? And let's see how the implicit conversions can cause a problem. Now here I have 2 select statements, and it's joining to another table. This is a date table, and what it has is it just has dates broken up into various parts so that I can look for holes in long ranges of dates and do other date manipulation. And so here we're going to join to the actual date field, and here we're going to join to it using the text version of that date. And now we're going to go ahead and run both of them. And I meant to turn on execution plan. Okay, so let's do that again. And we get, if you look down here in the bottom corner, you can see that, wow, that's an awful box, but there's 23,000 rows, and the second data set also returned 23,000 rows. When we look at how it performed here, we can see that they have the same number of scans and logical read on both of them. The second one did have a lot more CPU. It was more CPU intensive. When I look at the execution plan, they're roughly the same. If in 2012 they start getting better about giving us cues in our execution plan, and we can see that there is an exclamation mark over our select icon. When I hover over it, I can go ahead and see that down here that I have an explicit conversion. Now if I don't have that visual cue, or I don't see that in that pop-up list, the other way that I can look to see if I have any implicit conversions is to look at the raw XML. Now you might be saying, Nikki, I don't like reading XML, I'd rather not. Well, I'll show you how to quickly find the implicit conversions. I'm going to go ahead and say show execution plan in XML, and now all I have to do is find the word implicit, and it takes me directly to an implicit conversion. So now I know that my field here that held text was converted to date for me. Now you're saying, Mickey, well, that didn't really have too much of an effect. Okay, well, let's take a look at some others. Now if I come down here, I'm going to go ahead and find a range of dates. Again, this is going to give me all of 2005. And let's see what happens when I run both of these. Wait a minute. First one gave me 23,000 rows again. The second one gave me nothing. Why is that? Well, we can see right here why. The sum date, it converted these strings to dates and gave me the right dates. But this is text, and this is text. So it treated the dates like text. And look at how the dates are stored in there. 2005 first. There's dashes and leading zeros. This didn't have that. So now if I have to use this particular field as a text and I don't use these as dates, I have to make sure that it's laid out exactly like this in order to get the correct data back. And that's something that can really trip you up if the user is having to use this in a report and they're inputting dates themselves. Let's take a look at another one. Okay, this one is using a number range. Now here has the leading 0. Here as a number has the leading 0, and mathematically we know that leading zeros don't mean anything, so this is really 100 to 2,000. Let's go ahead and run this. And here we get something different as well. The first one has 190,000 rows, and the second one has 19,000 rows. So here we can see again that implicit conversion failed us and gave us the wrong data. So we really want to make sure that if we are stuck using incorrect data, that we go ahead and we use the convert function. And let's take a look at this here. Oops, I ran everything. Let's do that. And now we get 19,000 again. Well, that's because here we need to convert these to, oh, because I converted the wrong one. Ha ha ha. Let's do that here. There. Grant Fritchie always says, don't type during demos. And there we go, 19,000 and 19,000. And they match again. All right, any questions?
Let's see.
You're on mute.
Yes, I was. Let me go back. There was a few. Let's see. Did you say deterministic or non-deterministic is better for performance?
Deterministic is better for performance.
And if you haven't got this already, Jason asked another question. What's the link to your blog? Because I know that you and I had talked, and if we didn't get to all the questions, you were going to blog about this afterwards. If you want to give that now, this is a good time.
It's, let's see, I think I have it on a previous slide here so that you don't have to worry about my spelling of my name. It's MickeyStuewe.com, and Stuewe is U-E in the middle.
Okay. This was a ways back too. Can you give an example of commenting within a stored procedure? But I think you've already done that. So let's just continue. I think.
Okay. I'll give some examples for that one in the blog post too. Talked about that. Oh, okay. Here we go. We have three different ways of holding data in different types of tables. You have temp tables, table variables, and materialized tables. Now, materialized tables is a fancy way of saying the tables that we have actually in our database. And the reason why I'm listing this with temp tables and table variables is sometimes people do use them in stored procedures as a temporary storage mechanism, and so I wanted to compare all three of them. Temp tables and table variables are both stored in TempDB. So it is a urban legend, I guess you could say, that table variables are stored in memory. They're not. They're actually written to TempDB. All of them can be indexed. Each person has their own copy when using a temp table and a table variable. Yes, there are global temp tables that has 2 pounds in front of it. I've never used them. You got to be careful because that means you've got people sharing data. Materialized tables, multiple people can overwrite each other, so you got to be careful if you are using that. It's not something I would recommend unless the data is supposed to be permanent. Here is the gotcha. Temp tables will estimate based on n rows. Table variables will create their estimates based on 1 row. 1 row. You put 1,000,000 rows in a table variable, when it's calculating the best execution plan, it's going to think it's got 1 row. And this is going to be really important later when we talk about some other structures in SQL Server. Materialized tables will be based on n rows. Now, what are these estimates coming from? They're coming from statistics. So statistics will be on your temp tables and they'll be on your materialized tables. And this will determine what the best execution plans are. The table variables, 1 row. That really stinks. So what is the best use of these? Temp tables are great inside of stored procedures when you have some transient data that you need to keep working on. Table variables, when you're going to put really small data sets. You know you're going to have 1 row, you can use a table variable. You know that maybe 10 rows. There's a lot of different discussions on there on what the max number of rows to put in a table variable. That's something that you have to decide for yourself. Materialized, sorry, I pushed the button again. Materialized tables, that's if you're going to be using them inside of stored procedures, a lot of times they're used as staging tables when you're working with SSIS and you're moving data to a warehouse. Just make sure that you've just got that one process going against that table so that you don't step on someone else's work. I think I had a demo, so let's go ahead and look at that table here. Sorry, that demo. So I need to make sure that I turn my execution plan on, and we're going to go ahead and take a look at how much data is in here. This particular table has 1,000,000 rows, and I'm going to go ahead and run the whole thing because sometimes this particular demo can take a while. So now let's take a look at what I ran. I'm going to create 3 objects. I'm going to create a materialized table, a table variable, and a temp table, and they're all set up exactly the same. Yes, I know they have no primary key. It's not important for what we're doing. I'm then going to insert the data from that initial table into all 3 of these structures. I turn statistics on because I don't care about the statistics for this demo for the other query statements. I'm then going to connect, I'm selecting from all 3 of them data for a particular date. I'm going to turn statistics off and then drop my objects so that they don't continue to exist in my database. So now let's see, we've got our data back, and let's go ahead and look at the messages. Now the first thing that we can see is this guy right here. This is our temp table. It's got our temp table name, and this really long piece of information is making sure that this temp table is unique for this user. The second one we see is our materialized table, and then right here, this is proof that our table variable is actually a temp table under the covers, and they all had logical reads the same. So now let's look at the execution plans. The execution plan is showing the inserts and everything, so we actually want the last 3 statements. And here we can see the temp table, the materialized table, and the table variable. Now look at this is not being accurate, right? We have 4% and then we have 0% here. Why is that? Well, if we hover over here and I zoom this out, we can see that the estimated number of rows, oops, wrong one, estimated numbers of rows is actually 1. What? Well, that's because it's a table variable. If we go ahead and look at this guy, we can see that the estimated number of rows here is 63. Why is it 63.4029? That's because it's based on statistics. Okay, and we can see we get that exact same number on the temp table, 63. So right there we can see that it's lying to us and that there is more than one row. Okay, so let's go ahead and look at user-defined functions. Oh, when I first saw these, I was a happy girl. And then I took a presentation from Grant Fritchie and he popped my bubble, because user-defined functions are not as good as they sound. They are great for consolidating chunks of code, but they have some gotchas that you may not be aware of. For instance, there are three types of user-defined functions. The first is the scalar function. You usually find these in your select portion of your statement, and they will return one value or one piece of data. The problem is that scalar function is going to run for every single row in your query. So if you're returning 1 million rows, that scalar function is ran 1 million times. And if you put an entire query in that scalar function, then that query inside there is also ran 1 million times. And I'll show an example of that, how you can see that in a minute. The second type is the multi-line table function. When I found out scalar functions were bad, I changed everything to multi-line table functions. What's the problem with the multi-line table function? It returns a table variable. What? How many rows is it going to think it's returning? One row. Oh, we're not getting any better here. So what's the third type? The third type is an inline table function, and what it returns is a table. And I have an analogous to thinking like a temp table. So you are going to get statistics. I also kind of think of the inline table functions as it takes the innards of that inline table function and plops it right into my execution plan. So I get the full benefit of the execution plan. And we'll see with the multi-line table function and the scalar function that that's obfuscated for us. And that's not a good thing. Now, I didn't have much negative thing. I didn't have a lot of negative things to say about inline table functions. So the only bad thing I could say is that a subquery will most likely perform better. But if you need to encapsulate that data so that it can be used in multiple stored procedures, then a table function is a good thing to use. An inline table function. Now, I use an inline table function to split strings into table, because that is something that gets used quite a bit when I'm working with reports. So let's look at some demos for this. So what we have, I'm going to go ahead and turn these on, and I'm going to turn my execution plan on here. And what we have here is I have a, gosh darn it, oh, I apologize, let me refresh my suggestions so that you can see this. Nope, it's not turning on for me. Okay, what we have here is a scalar function, and let's go ahead, let's see if I can get it to open up for me. Oh, it did open up. This is what it looks like. It's not very exciting. It is going to go ahead and return the summation of some subtotals to help calculate commissions, okay? I'm using it twice in here. Okay, it's used twice. So I've got the scalar function is going to execute twice for every row that is returned. I can go ahead and see that. It brings me everything. The messages. Wait a minute. Let's take a look at that. Inside here again, what table were we using? We were using the sales order header table. But when I look at my statistics, it's not there. We only have salesperson because it's being obfuscated. And here when I look at my execution plan, it shows a clustered index on salesperson. It shows a compute scalar. This and it's not showing what is going on with that scalar function. So how can we see what is going on? Well, there's two different ways. One is to turn Profiler on. Let's go ahead and start a new trace. And I have a template already set up here. I'm going to go ahead and start it. And we're going to run that query again. And now let's go look at the trace. And what we can see here is that inside of that scalar function is ran over and over and over again. Okay? Now, how else can I see this? Well, SQL Sentry has a product called Execution Plan Explorer, and you can see what's going on in here as well. And so what I'm going to do, and it's free by the way, that's why I mention it, I already have my execution plan here, and they have a plugin that you can put in called View with SQL Sentry Plan Explorer, and it'll take the plan directly into the product. They do have a paid version as well that adds some extra functionality, but if you don't need to be in here all the time, then it's not necessary. Oops, I did that wrong. Let's go ahead and copy it. Copy. And I'm going to go in here and start a new one. I'm going to paste it in, and I'm going to run it. And we can see in here as well how many reads is occurring for each of those that is occurring inside of what we thought was a simple select statement. Okay? Do be careful. I wouldn't try looking at this if it returned a million rows. I have crashed this product by doing that because it returned a line for every single one of those scalar functions. So let's go ahead and look at some others that we have because I am taking a long time. So let's go ahead and we have, I'm going to run all of these at the same time because my variables are at the top and I wanted you to see each of them. So here what I did is I took the innards of that scalar function and I went ahead and put it into a multi-line table function. And if you haven't seen one of those, let me go ahead and open it up here. The select statement looks the same. There's a begin and an end. It has a return at the end, and here it's returning a table data type. Okay. Now, the reason why I'm really pointing that out is if you're not familiar with user-defined functions and you want to go see what the difference between the multi-line and the inline, those are some key aspects. On this particular one, this is the same thing, but it is an inline table function. So it returns the word table, and everything is encapsulated into one SQL statement with the return at the top. So now you can tell the difference between an inline and a multi-line table function. When I look at the data, the messages, the first one we saw only had salesperson. The second one, we can see our table variable right here with the pound symbol and the salesperson. That was using the multi-line table function. Then down here, this is using the inline table function. So now we get to actually see the sales order header in our statistics here, as well as a work table that it needed. And then I wanted it to compare it to what it looked like if I would actually use a subquery. Okay? I can see the CPU time is different between the two, as well as the elapsed time. Okay? When I look at the execution plans, the very first one we saw that there was information being obfuscated. The second one we see this is using the multi-line table function. Right here it's showing us the multi-line table function. And where's my pop-up? There it is. Oops, it went away. Here if you, come on. Here you can see that it is only returning one row per, it's showing 17 executions because the multi-line table function was returned 17 times with one row each. And down here we can see that we get a different execution plan because this is using the inline table function, so it's actually bringing the sales order header into the execution plan, and it's the same one that we saw for the subquery. Okay. I'm going to have to take questions at the end because I have two more points and I have a little less than 5 minutes. So we have cursors. Cursors will hinder your performance, and you need to think about when to use cursors. There's a lot of times that you can rewrite cursors in different ways. You can rewrite them using common table expressions, and sometimes using an inline table function with a cross apply will help you get away from cursors. Because what you can see is that the data will, or the SQL statements in the cursor will repeat over and over and over again inside a cursor. It's interesting that there is a misconception out there about while statements. I've given several interviews asking how could you write a cursor differently, and I've been given the answer of, well, I would use a while loop. A while loop is a cursor. Think of cursors as that data being repeated over and over again. And I included scalar functions in here. They are not cursors, but they act like cursors because it's going to execute over and over again. And to the right, I put some numbers to show you what will happen when you're using cursors in terms of performance and that those tables being hit over and over again. And let's take a look at that. Okay. We saw how the the scalar table occurred, and let's go ahead and I need to turn statistics and my execution plans on. What we have here is a table that has a comma delimited string. Please don't do that. That is not good table structure, but it will work for our presentation. So we have our cursor here, and what it's doing is it's breaking up that string and returning, and then summing the digits and returning that value. And when we look at it, we get 45 for each of them. When we look at the statistics, it's hitting those tables over and over again. And when we look at the execution plan, we can see the inside, the same execution plan was used over and over again. Okay. So what about a while loop? Is this one? Yeah, a while loop, and we're going to look at it. It's doing the exact same thing, but set up as a while loop. Here we can see that the data is used over and over again, and again in the execution plan, the same thing. So now I've done the, well, here it's going to do the same thing, but it's obfuscated, right? It just says parse example, but we saw if we use either trace or the SQL Sentry's Plan Explorer, you can see what is actually going on inside. So now I've rewritten it, and here we can see the inside of my inline table function. And it's using the exact same thing. It's using the with statement to separate out the digits, and then it goes ahead and sums them all and returns it. And so now when I run this one, we get 45s, and we get one execution plan with everything going on. And in the messages, it has still a lot of logical reads, but it's working in a better way. Okay, so let's go ahead and look at the last one, the last slide that we have. Select star is bad. Oh, I see these still. They really need to go away. They are wonderful when you're working quickly to figure out how things should be, but then you really should actually state the different fields that you actually need. The reason for that is there's 4 different reasons. One, if your DDL changes, the DDL is your table structure. If it changes, it's going to return different data. So if you have a table that had 5 fields and then you change it and it now has 8 fields, your select star will now return 8 fields. And that can mess up some products. The older versions of reporting services, it didn't like that and it got mad. The newer ones will just ignore those 3 fields, but the execution plan will be affected underneath. What else do we have? If your table, maybe someone changed a field name, which is not always a good idea once that table reaches production, and you have select star, it's now returning a different field name, and that could mess up an application. You'll be returning more data than you actually need, and it can lead to a poor execution plan. And let's take a look at this last demo. So what I have here is I have a select statement, and it's using an index seek, which is the best thing that we can use. It means it's getting just what it needs out of that index. Someone went ahead and added a new column, and the select seek is now an index scan. So now it's having to scan the entire table to return the same data. So now if that field wasn't even needed, then you've just hindered performance. And it can hinder performance in either more severe ways when the query is more complicated, like introducing key lookups that may not have been needed if you had a good covering index in the first place. So I know we're out of time, and some of you take just your hour break. So I wanted to point out that we did cover all of our different objects. I will stick around to answer some questions, but I'm going to go ahead and show my last slide here for those of you that will have to take off early. And then I'll take the questions after, and I'll leave this up as much as possible unless I have to go show something in SQL. So you can download the presentation from my website on the Resources tab. When you click on it, there's a section for presentations, and my demos should be there. If not, I'll put them up. You can contact me to ask additional questions through my email or on Twitter. One thing that I'll tell you about Twitter, I talk about 4 things. I talk about SQL, I talk about my kids, my new puppy, and whiskey, because I love whiskey, which is why I was in Louisville when I met Steve to speak at the conference and to go whiskey tasting. Online, I blog at mickeystuewe.com, and also I run a local BI chapter. We talked about my book and my words, so I will answer questions now. So go ahead.
Okay, and some of these may go back a little bit. Is there a difference in improvements in using a cast versus a convert?
No, there is not. You can use either of them. It's really a preference for you. I'm a convert girl, but sometimes I'll go and use cast. I don't really, there's not a preference.
Okay, good. This person, Mantis, said that he was told it was a good practice to put a semicolon at the end of T-SQL sentence. He didn't see one in the demo. Is that correct or not? Or does it make a difference?
That is a great question. They are not needed 99% of the time. I'm going to answer an additional question while I answer that. So I see a question someone asked what a CTE is. It's a common table expression. Those are the parts of the code that started with, and they require that the previous statement have a semicolon. Merge might, I can't remember. So semicolons are not required 99% of the time, but Microsoft has stated that at some point they are going to make semicolons required, and it is a really hard habit to get into using semicolons, which is why you didn't see it in all of my code. So what I would encourage you, especially if you're new to writing SQL, is to start using semicolons so that you can get in the habit. Now, I hope some of you don't think I'm using this too much, but Redgate SQL Prompt had a brand new release, and one of the things they had in there is the shortcut Control-VC. It will go through and add semicolons to all of the statements. And I am so happy because now that's just part of my ritual when I'm formatting my code. I don't have to think about it, but before I put that statement into existence, I go ahead and stick semicolons onto everything. These demos predate that release, and that would be the other reason why there's no semicolons. Go ahead for the next question.
Okay. Let's see. This user wanted to know if there's a standards document out there from Microsoft about T-SQL formatting.
I don't know if Microsoft has put one out there. I have seen various people blog about it. They tend to have a very long comment thread afterwards as people debate on what the best standards are. If you are looking for some, I can give you my opinion in an email. You could go ahead and email me, and I can't share my particular document, but I can write something up for you. But that would just be my opinion. What I would do is take a look at various people's opinions on it, and I call them opinions because there's no right or wrong answer. And you can look at them, look at your existing code to see what matches the best. Because while I say semicolons should always be on the left, if 90% of your code has semicolons on the right, then that's probably a better standard to implement at your company. And if I were to go into a company that had commas, that's what I meant to say, on the right, I would adapt and start having commas on the right.
Okay. This Alex asked the question on the comparison of temporary table variables and materialized tables. Why was the second execution plan eligible for auto-parameterization and the others were not?
That one I will answer in a blog post because I would have to go look that one up.
Okay. What is the proper way to use the distinct with lots of columns on the select without duplicate records? Per our SDLC, avoiding using distinct with lots of columns. Thank you. You might want to look at that to be sure you understand that one.
So I don't know where that is in the list. Are you looking at the top?
Four from the bottom.
4 from the bottom. So the reason why they're saying not to use distinct is it's almost like using a group by. What is happening under the covers is that all the data has to be looked at to make sure that there's not duplicate rows. And that has a performance hit because now it's having to look at the entire index or the entire table, depending on if it's using the primary key index or another index. So that's why they're saying not to use a distinct. Sometimes you cannot get away from using a distinct if there is duplicate data, and to me that is justification. If you can go to your manager and say, when I write this query, because of the type of joins that are occurring, I'm getting duplicates and I need to suppress them. Another way that you might be able to get away from the distinct is look at the joins. Maybe you're missing part of a join that could help remove those duplicate records, maybe by adding an AND statement and joining on a second field. I have seen that work because the person didn't know that it was a composite primary key, and they only had one of the joins, not both of them.
Okay. This is not a question, but it's a statement. It's a nice little thing to know. Jeff pointed out that CAST is ANSI compliant, whereas Convert is a Microsoft specific. So if you're developing code that might need to be used on other systems, it could cause you problems. So that's a reason to maybe use CAST sometimes.
Yes. Yeah, and there's several other functions out there that I've seen that way. I worked at one company that didn't use getDate. They used another function to return the date because of similar reasons.
Okay, here's one I missed. Gail asked the question, is there better performance between CTE or apply?
Okay, I think I saw that. Was that at the very end?
That was about 10 up. I missed it. It was a small one. 12:03 p.m.
I'm not seeing the dates. Come on.
Received.
There we go, 12. Oh, I have different times because I'm in a different time zone.
Okay, sorry.
Okay. Let's see. Oh, wait,
so
there it is. Is there better performance between CTE and apply? Okay, so the apply operator is can be used outside of the CTE, a common table expression. Let's see, I have one in here. Here is a common table expression. It starts with the with statement. It allows you to have a select statement inside, and then you follow it by another statement. It can be a select, an insert, delete. And so what it's doing is it's working through this select statement and then allowing you to select on it again. So the cross-apply operator is separate from that. You don't have to use the cross-apply with the CTE, but what it does is it joins the data differently, and I can expand upon that even more in a technical way in the blog post, because the cross-apply operator and there's an outer apply operator are wonderful operators to use.
Okay, it just keeps growing now. People are really rolling in the questions. About predicate and especially like, we know that to put predicate is more efficient. We shouldn't start by a wildcard, but if we need to return data that ends by defined string, does there exist a way to improve that?
Oh, because it needs to end in it. So some things you might want to think about. I don't know what your particular case is. If you know you're always using those last 5 digits, what you might want to consider is actually having a separate column with those last 5 digits in your table. That may or may not be a possibility, but that would allow you to index that and provide better performance. An example of that is the name column. Instead of having first name, last name in one field, always separating it out into 2 fields so that you can do searches on the last name. And it may not be something that you can get away with. You just need to know that your index will not perform the best. Well, it won't use the index, or it might use an index scan instead of an index seek.
We're going to have to save the rest of the questions for your blog, not
Okay.
because we can't stay on. It's just that my boss is eating food in the office here, and it's driving me crazy in my backyard. So, but anyway, you've got a bunch of questions. They just keep rolling in. Some of them like, what's your favorite whiskey? That's not necessarily SQL related, but you can answer that in the blog too. Anyway, I just wanted to award the Amazon card that goes to Charles Kipley. He may or may not still be here, but we'll get in contact with him afterwards. And just remind you about our webinar next month on November the 11th with Ami Levine about in-memory OLTP. And Mickey, thank you. You've been great. Obviously, by the number of questions we've got. So people can still, I'll tell you what, I'll leave it up for another 5 minutes. You can still add in some more questions, and Mickey will answer them via her blog post. Thank you.
Yeah, you're welcome. Everybody have a great day.